Okay, so this week we're going to try to finish up consumer theory. We had started about half of lecture 8 last week, and there was maybe 4 or 5 slides left that I want to cover, but I'm going to kind of review where we were, even though lecture 9 also starts with a review. I'll just skip that, review it now, and then we'll go into the rest of lecture 8. Okay. Okay, so we talked about utility and marginal utility. Remember, utility is a way of ranking your choices and assigning them a variable or a number that corresponds to some sort of pleasure. So if your utility of eating an apple is X, your utility of eating a banana is Y, you can say something about if X is greater than Y, then I prefer apples to bananas. Okay, that's what utility allows you to do, is compare options. Okay, and then marginal utility would be the extra utility you get once you've consumed the next additional unit of a good. So if an apple is X, if your first apple is X, your second apple is Y, your third apple is Z, X plus Y plus Z is your total utility for 3 apples, but your marginal utility will be Y for the second apple and Z for the third apple. So it's just the utility you get from the second unit, only the second unit, not the first and second unit combined. Okay. And typically when you consume more of a good, the marginal utility is going to drop. So, if you have, 5 apples, you don't really care for apples anymore. Maybe you're satisfying hunger, but the pleasure isn't there from eating that 5th apple. If you're really hungry, the first apple is going to do a lot for you. Second one's going to do some, but not as much as the first. Third is going to do less. Fourth is going to do less. So your total utility will continue to increase, but the rate of increase is going to start dropping as you consume more and more and more. And we call that diminishing marginal utility. The rate of increase in utility is dropping. The rate of increase in utility is your marginal utility. We can track marginal utility as the slope of the utility function at any particular point. Okay. So if I took a tangent from here, the slope is pretty high. Okay. That means at early consumption, like at early quantities of consumption, I have a high marginal utility, right? My slope, my slope is going to be pretty high. Okay. At this point, though, my slope's going to be pretty flat. And at this point, it's almost horizontal, not quite, but almost horizontal. Okay. So maybe the slope here is like 10. Okay. So we can go up to like 10 on the consumption, 10 on the marginal utility. Maybe the slope here is like 2, and the slope here is close to 0. Okay. So if we were to plot the slope of each point, we would have this curve. So the slope at this point corresponds like here. Slope at this point corresponds like here, et cetera, et cetera. And this is just the marginal utility at every point. It corresponds to the slope of the utility function at every point. But the bigger picture is just that marginal utility will drop as quantity increases. Okay, and that there's nothing baked in about that. There's nothing. It's not a law in the sense of it's always going to apply, but it tends to apply in the real world, and for that reason, economists will typically assume it in their models. It's not a necessary thing. It's not something you have to assume, but it's pretty common, and it's common enough that we call it a law, even though there's nothing necessarily inherent about it. Okay, it's just consumption patterns. We just like a mixture more than we like like a lot of one particular good. Okay. So we talked about marginal analysis, which is the benefit or cost you get from the next additional unit, just like marginal utility is the benefit from, or marginal utility is the utility from the next additional unit. Marginal benefit and marginal cost are the benefit and cost of the next additional unit. And marginal benefit and marginal utility can typically be interchangeable, so just keep that in mind. Then we did this exercise where we had a list of utilities, a list of costs. We found the marginal utility by subtracting this from this, and subtracting this from this, and this from this. So we had 10 and 2 and 0.5 and 0.25. And then 3.5, 1.5, 0.75, 0.5. And I asked, when should Abby stop buying beer? And the idea was that you're going to stop buying beer as long as your marginal utility is greater than your marginal cost. So marginal utility is greater than marginal cost, continue to drink. Okay. Marginal utility is greater than marginal cost, continue to drink. And then here, marginal utility is less than marginal cost. So somewhere between 2 beers and 3 beers, you're going to want to stop. But since he can only buy beers, you can't buy half a beer, we said 2 beers. Okay. So 2 beers is when he should stop drinking. And the reason is because after 3 beers, the cost isn't worth it anymore. The amount of happiness you get from that third beer, 0.5, is less than the amount that you pay for that third beer, 0.75. Okay? And that's called marginal analysis. You're going to stop once your marginal cost is greater than your marginal benefit. Okay? So if you could drink in between beers, like if you could drink 2.25 or 2.249 beers, you'd stop at the exact point where your marginal cost is equal to your marginal utility. And as long as you can find something that's where your marginal utility is greater than your marginal cost, you'll keep consuming until they equalize. And then once they equalize, if you go any further, then your marginal cost will be greater than your marginal utility. You're going to stop. Okay. So then I talked a little bit about the sunk cost fallacy, and I compared it to my time in PhD or my ex-girlfriend, 2 of the worst times of my life, where I kept justifying behavior based on the time that I spent like fostering the relationship or studying or whatever, but not based on the marginal utility I would get from the future versus the marginal cost I would pay in the future. Right, which is what really you should be doing when you're doing marginal analysis. And the reason that this is considered a fallacy or like an error is that if you're only looking at past costs, well, you can't recoup them. You can't get your past back. So justifying something based on the past doesn't make a whole lot of sense. Sorry, I'm getting cat. My cat like jumps up here and I'm getting cat fur all over my nose now. But so let's say you spent $100 on beer, but the beer's gross. Well, if you're applying the sunk cost fallacy, you're going to continue to drink the beer based on the amount you spent, not based on the marginal utility you get from that beer, right? And it's really the difference between marginal utility and marginal cost that you want to make your decision based on, not the amount that you spent. Because you could have spent any amount and your marginal utility and your marginal cost would be the same, but you're not getting that money back, so it should not have an effect on your future decision making. Okay. So that's really it. So don't use sunk costs; they're bad. It's a bad method of justifying behavior. So try to use marginal analysis and marginal cost or marginal analysis. Comparing marginal benefits to marginal cost in your decision making in life, and you'll probably find yourself a lot happier. Okay, you can't get the past back. So then we talked a little bit about consumption bundles, and what a consumption bundle is it's a way of representing a lot of different items that you can eat or drink or consume in general. I don't know why. I stick to eating because I'm always thinking about food. That's why I've gained 20 pounds since I've been teaching you guys. So So let's say you go to a restaurant and you can get pizza, mozzarella sticks, chicken fingers. A consumption bundle is a way of mapping the amount of pizza, mozzarella sticks, and chicken fingers to utility, or that you eat or consume in general, to your utility. Okay. So prior we were just looking at the utility from eating one slice of pizza versus the utility of eating two slices of pizza. Well, now we can have the utility of pizza, mozz sticks, and chicken fingers represented as one number. Let's call it Z. Okay. So this is your consumption bundle right here. Your pizza, mozzarella sticks, and chicken fingers, the combination that you eat that you consume of them. And this is your utility. So I say consumption bundle is an n+1 dimensional utility function, right? So this is the utility function. Your utility of P, M, and C, pizza, mozzarella sticks, and chicken fingers, is equal to some number. Okay, so if we were to plot this, it would be a 4-dimensional graph, which I'm not actually able to draw. You can't really draw a 4-dimensional graph on one surface. So we tend to use what's called an indifference curve. Okay, and an indifference curve is a way of mapping the combinations of pizza, mozzarella sticks, and chicken fingers to a particular utility level. But even then, if we use an indifference curve for 3 goods, it's still going to be 3-dimensional. So we might say we'll typically use 2 goods. So we might have pizza, mozzarella sticks, and then some utility here. And we're just going to ignore chicken fingers for the time being, just because it's hard to draw. But you could do a 3-dimensional utility function, and there's nothing impossible about it. It just look like this and this, or whatever. It's just hard to draw It's hard to draw on PowerPoint, but they exist, and you can do them on different software. So I would use MATLAB if I wanted to draw a 3-dimensional indifference curve. But basically, an indifference curve is a way of flattening your utility function to something a little bit more manageable. So we'll typically look at 2 goods, and I'm only going to give you 2 goods. So ignore chicken fingers for a second. But on one axis you're going to have one good, on the other axis you're going to have another good, and then you're going to have a bunch of lines that correspond to different levels of utility. So this utility might be equal to 2, and this utility might be equal to 1, and this utility might be equal to 2.5 or something. Okay. And the further you go northeast, the higher your utility is, as long as you like both goods. Okay. I'm getting really messy over here, so I'm going to jump on to the next slide where we actually plot some indifference curves. Oh, hey, that's gross. So let me just read this out. So indifference curves flatten the utility function. I already said all this. Okay. So if you have Abby who likes beer and samosas, you can have different consumption bundles. Oh, hey, what just happened there? Different consumption bundles of beer, samosas. So these are 3 separate consumption bundles. 4 beers, 1 samosa. 10 beers, half a samosa. 8 beers, 8 samosas, 1 beer. I don't know why I flipped it that time. So 1 beer, 8 samosas. You can draw 1 beer, or beer on one axis, samosas on the other, and you can have like 4-1, 10.5. So let's say that's 10.5. This will be like 4-1, and then 8-1. 4 beers. So 4 beers, 1. I don't know exactly how I plotted them, but I don't know how to plot them to scale. But you can connect them. So this could be like, what was it? This is the most number of beers, so 10, 0.5. This will be like 4, 1, and this here point will be 1, 8. And all 3 of these points yield the utility of 5. So they're all on the same indifference curve. They all yield the same utility. But you can have higher utilities corresponding to higher consumption bundles. So if we went directly up to like 4 beers, 9 samosas, it's going to be on a higher indifference curve because you like both beers and samosas. You're consuming the same amount of beer but a higher number of samosas. So you'd expect your utility to be higher. If you go over here, this could be like 7,8, right? So these two might have the same utility. I don't know. This is just random numbers that I'm pulling. But this, as long as you're consuming more beers and more samosas, it should be on a higher indifference curve. So I'm going to erase this. I'm going to show you an actually well-drawn indifference curve so that y'all can see it without my scribble scrabble. Okay. So here's there's 3 points plotted on one indifference curve. And of course, you can have higher indifference curves corresponding to higher goods. Okay. So the utility from higher indifference curves is going to be higher than the utility from lower indifference curves. And they're called indifference curves because you're indifferent between this bundle, and this bundle. They all yield the same utility. So if someone presented you 3 options between 0.5, 10, 1, 4, and 8, 1, you'd be like, I don't care, give me whatever. But if you're presented these 3 options and an option on the 7 curve, you'd obviously prefer the 7 curve because it gives you a higher utility. So these indifference curves are going to be strictly preferred to consumption bundles on these indifference curves are going to be strictly preferred to consumption bundles on this indifference curve. Okay. And then the last point I want to make is that, see how they're shaped like this, right? They're curved out. Well, obviously they're curved because they're called indifference curves. But a curve could be a line. Curve just means, this corresponds to a function. But the reason it's curved out, like curved in this shape, is because we tend to have preferences that if I'm consuming a mix between samosas and beer, I tend to prefer that to consuming an extreme amount of beer or an extreme amount of samosas, right? If you went to McDonald's and they offered you 50 chicken fingers or chicken nuggets or whatever, you'd be like, that's way too many chicken nuggets. And if they offered you 1,000,000 fries, you'd be like, there's way too many fries. They offered you 3 things of large fries and a thing of 20-piece McNuggets. You'd be like, that's too much fries. Or sorry, let me start over. If they offer you 3 things of large fries and that's it, you'd be like, that's too many fries. I'd rather have some fries and something else. Or if they offered you a thing of like 40 McNuggets, you'd be like, that's way too many McNuggets. I want maybe 10 McNuggets and a little bit of fries. I don't need 40 McNuggets. I don't need 3 things of large fries. I'd rather have something in between, right? Your preferences tend towards the combination, right? The combo versus a high amount of fries, a high amount of McNuggets. Okay? So if you prefer like a medium amount of McNuggets to a high amount, or let's say this is McNuggets now, MN for McNuggets, and this is now fries, you'd prefer a little bit of fries, a little bit of nuggets to a high amount of McNuggets, no fries, or a little fries, and high fries, very few McNuggets. You'd prefer like a mixture of them. That's not drawn well. Let's try that again. So if you're to like draw a straight line, come on, I cannot draw. I'm trying to draw a line between these 2 points here. Okay, so if you're to draw a straight line between these 2 points, and then a corresponding utility function, imagine that those touch, right? So this is like an average line, right? If you're combining the two with what's called the secant line, this is like every combination of chicken fingers and McNuggets that will be like somewhere in between, like some average amount of chicken fingers and McNuggets between the two. So you prefer the average amount of chicken fingers and an average amount of McNuggets to an extreme amount of chicken fingers and an extreme amount of McNuggets. So they actually fall on a higher indifference curve. Okay, this indifference curve would probably be like U equals like 7.2 or something based on how I drew it. But whatever. So the shape of it means that if you were to draw a straight line corresponding to an average amount or less chicken fingers, more McNuggets, going like from here to here, and like more McNuggets. Sorry, those are the same thing. Less McNuggets, more fries, or more going from here, more McNuggets, less fries. You prefer the combination that leads you somewhere towards the middle. So that's why the indifference curve is shaped like that. And that goes back to this point I made earlier about, where'd it go? All the way back. Still further back. Oh, come on. There we go. About diminishing marginal utility. If you eat an extreme amount of chicken fingers, your marginal utility for chicken fingers is going to go down, right? So if this is like your utility from chicken fingers, if this is your total utility from chicken fingers on here, and the red line is your total utility from fries, you'd rather get somewhere over here, like, and you were to add these two up, you'd rather get this one and this one versus like this one and like a low amount of fries, right? You'd rather get the average and add these up rather than have this one and this one, or like this one and this one over here. Probably didn't explain that very well, but the point is that if you consume more fries, the additional fries you get. So if you go from 1 large fry to 3 large fries, your marginal utility of those extra 2 large fries is going to be very low. But if you take that same money and you put it to a chicken finger, the marginal utility for 1 chicken finger is going to be pretty high. So you'd rather get some mixture between chicken fingers and fries. I keep saying fingers, but they're really McNuggets, I guess. Whatever, they're the same thing. The money you spend on, and if let's say you have an extreme amount of chicken fingers, the money you spent on that going from 20 chicken fingers to 40 chicken fingers, you'd rather spend on large fries because the extra fries, when you have no fries, is going to have a large marginal utility, right? So anyway, that's the shape of an indifference curve. It's always going to be, or not always, but it should be curved out like that as long as the law of diminishing marginal utility holds. Okay. And that's basically where we left off. So we're going to continue with the last point. If you had utility functions, indifference curves like this, something has to be wrong because your indifference curve should map to one utility. So if you have like utility equals x here, and this one here is utility equals y, this consumption bundle right here between good 2 and good 1, this consumption bundle, you don't know what the utility is. You can't know what the utility is because it could either be x or y. It doesn't make sense. How can one consumption, like one set of McNuggets and fries, give you both utility of x and utility of y? That doesn't make sense. It's the same bundle. So it has to be consistent. So if you have indifference curves that cross each other, you've done something wrong. It doesn't make any sense. Okay. So that's the recap. So we're going to move on now.